Hi, we're going to take a look at volume applications. So one of the applications would be to find volume of composite figures. A composite figure is a new figure combining two or more solids. So first we separate the two solids and we find the volume of each, then we add or subtract those volumes together. So in our first example, we have a triangular prism that has a cylinder drilled through the middle of that triangular prism. So we're going to break this down into a triangular prism and a cylinder. So the triangular prism has measurements of 5 and 5, and then the space of 7.1. So I'm going to go ahead and draw a quick sketch of this on the side so that we can take a look at what we're going to be having to do. To find the volume of the triangle, we have to create that height and figure out how long it is. So that height is cutting the base in half. So that 7.1 divided by 2 would give us 3.52. So we'd have 3.55 on each side. And then to find the height, we can use Pythagorean theorem. So we'd have height squared plus 3.55 squared equals 5 squared. So when you get h by itself, you would subtract the 3.55 squared on both sides, and then you would take the square root of it all. So once you take the square root of 25 minus the 3.55 squared, which is 12.6025, you get 3.52. We have the height of the triangle. We know the base of the triangle is 7.1. Then we have to plug that in to find the overall volume of that triangular prism. So we have the 1/2 base times height of the triangle, so it's height of the triangle, times the height of your prism. So 1/2, the base was 7.1 times the height, which is 3.52. And then finally, the height of the prism is 14. If we combine and simplify, we would get 175 as our total volume for that prism. And now we have to subtract the volume of the cylinder, which is pi r squared times h. When we plug that in, we know the radius is 2 centimeters. So that means the radius is 1 centimeter. So I have 1 squared times the height, which is the same as the prism, which is 14. When we combine all that, we get 14 pi. And then in my calculator, you would type in 175 minus 14 pi. That would give you a more exact answer. And when you round that, you would get 131 centimeters cubed. Our next example is going to be a composite function where we're adding two figures together. You would have to add the volume of your cylinder to the volume of your hemisphere. The volume of the cylinder, again, is pi r squared times h. The volume of the hemisphere would be half of a sphere whose volume is 4/3 pi r cubed. Now we can plug in everything that we know. In the cylinder, we would have pi, and then if our diameter is 22, that means our radius is 11. It would be pi times 11 squared times h, which is something that we don't know yet, because the height of 45 represents the hemisphere and the cylinder. So we need to figure out just the cylinder. And we can do that because we know the radius of the hemisphere is 11. So we can subtract 11 from the 45 to get just the height of the cylinder, which would be 34. So we would multiply pi times 11 squared times 34. When you plug all that in, you would get 4,114 pi. Now let's go ahead and figure out the volume of the hemisphere. So we already know it's 1/2 times 4/3 pi. We already know the radius is 11, and then we cube it. When you simplify all that, you would get 887.3 pi. When you plug this line, the last line, into your calculator to find your total volume, you would have 4,114 pi plus 887.3 pi, and as a decimal it'd be 15,712.05 feet cubed as your final answer. In our last example on this page, you'll see that you have a cone, but the tip of the cone is cut off. So we have to figure out the volume of essentially both cones. So I'm going to call this cone, the big cone would be, I'll just call it big cone, so BC for big cone. And the formula would be 1/3 pi r squared times the height of the cone. We're going to have to subtract I'm going to call it SC for smaller cone, which is the same formula, 1/3 pi r squared times h. The area of the bigger, or the volume of the bigger cone would be 1/3 pi. We know that the diameter is 19, so that means the radius is 9. So 9 squared, and the height of the entire bigger cone would be 10 plus 15, which would get us to 25. So we would have 25 as the height of the larger cone. If you simplify all that, you get 675 pi. Now let's go ahead and finish up the volume of the smaller cone, which would be 1/3 pi. We already established, well, our radius over here is no longer 9, but we do know up here that the diameter from here to here is 8, so the radius would equal 4. So it'd be 4 squared, and it gives us the height is 10 of the smaller cone. When you plug all that in, you would get 53.3 pi. We subtract the two answers, and you would get 1,953.13 inches cubed. And now let's go ahead and continue with the rest of our examples. We have another example of a composite figure where you have a trapezoidal prism on top of a rectangular prism. So our first one, we'll do the trapezoidal prism, so I'll call that T prism. And the formula for that is 1/2 the sum of your bases, so base 1 plus base 2, times the height. So think of this as kind of like the formula for triangle. It's just that you're adding your bases to get that measurement for the one base first. So this is for the trapezoid. Then we have to multiply it by the height of your prism. Let's go ahead and finish that one first. So we have 1/2. The two bases would be 6 and 17, so 6 plus 17, times the height of that trapezoid would be this length. However, we know the height of the entire prism is 22, but we know that the height of the rectangular prism is 8. So we can subtract 8 to get 14 as the height of the trapezoid. We multiply it by 14, and then we have the height of the entire prism would be this length, and we know that's 13. We're going to plug all this into our calculator in one go, and when you do that, you would have 2,093. Now we have to do the volume of the rectangular prism, which would be length times width times height. So we would have 17 times 13 times 8. When you plug all that in, you would get 1,768. We add these two answers together, and you would get 3,861 centimeters cubed. Our next example, we have an automatic water bottle feeder. We know that it is in the shape of a cylinder and a cone at the end, and we are going to find the volume of both, and because they're combined, we're going to be adding two volumes together. So the volume of the cylinder is pi r squared h, and the volume of the cone is 1/3 pi r squared h. For the first one, we have pi, and then our radius would be 3 because the diameter is 6, so it'd be 3 squared, and then the height of the cylinder is 8.5. When you put that all in your calculator, you get 76.5 pi. We're going to add that answer to the volume of the cone, which would be 1/3 pi. Well, we already know that the radius is 3 again, and then the height of the cone, we have to figure that out. So we would have to subtract 8.5 from 12.5, and you would get a height of 4. When you simplify that in your calculator, you would get 12 pi. Now we need to add those two answers together. So 76.5 pi plus 12 pi would be 202.63 inches cubed. Then finally, we have a hollow sphere inside a foam cube where the sphere touches each side of the cube, and we have to find the volume of the foam. In our case, same idea. We have to find the volume of the cube, and we have to subtract the volume of the sphere from it. So the volume of the cube would be length times width times height, but because they're all the same measurement, it's essentially one side cubed. So that would be 18 cubed, and that would be 5,832. And we subtract the volume of the sphere, which is 4/3 pi r cubed. When we plug that in, you would get 4/3 pi, and now the radius, if the length of the cube is 19, that means the radius is 9, so 9 cubed. When you plug all that in, you would get 972 pi, so 5,832 minus 972 pi would get us 2,778.37 inches cubed.